In this session, we're going to solve equations by factoring. And in order to consider that, we should start by looking at what's called the zero product property, or the principle of zero products. And it says if A and B are real numbers, don't let the symbols scare you, and if the product A times B is equal to 0, then we can draw one of two conclusions. Either A is equal to 0 or B is equal to 0. Notice that this doesn't tell you which one is 0, it just says that either one could be 0. Sometimes we can narrow it down though. Looking at something like 3x is equal to 0, well, we wouldn't say that 3 is 0 because 3 is 3. We could say that x is equal to 0, and that's in fact the solution to this equation. You'd get that same solution if you had divided both sides by 3, but this is just a different way to look at it. Using this idea, we can solve something like 3 times the quantity of x plus 5 is equal to 0. Well, again, 3 is not going to equal 0 because 3 is 3. However, x plus 5 could equal 0. If that's the case, then subtracting 5 from both sides gives us that x is equal to negative 5 as a solution to this equation. You can see in both cases that if we substituted the solution into the equation, we'd get a true statement. That is, if I put 0 in place of x for the first equation, 3 times 0 is certainly 0. If I were to put negative 5 in place of x in the second equation, then that factor would become 0, and I'd have 3 times 0, which would give me 0. Let's look at some more interesting examples. Here we have x times the quantity of x plus 5 is equal to 0. Here I have a variable factor on the outside of the parentheses, and it could very well be the case that x is equal to 0. Remember, a variable can represent anything provided there aren't restraints. X plus 5 could equal 0, and if it did, then subtracting 5 from both sides gives me x equals negative 5. Now the way you might write a solution like this would be, we can say x is equal to 0 or x is equal to negative 5. You wouldn't say and, because x can't be both 0 and negative 5 at the same time. That's one way you could write the solution. The other way you could write it would be to say x is equal to 0, comma, negative 5, and in that case the or is implied. You wouldn't have to write down both of these, but one of them should be present in your solution. Next we have 2x squared plus 3x is equal to 0. Here I see we have a common factor of x in both terms, and when we factor that out, we end up with something that looks a lot like what we had in the previous example. X times the quantity of 2x plus 3 is equal to 0. Again, x could be 0, or the other factor, 2x plus 3, could be 0. Here we have a linear equation that we would solve like any other linear equation. Subtracting 3 from both sides gives us 2x is equal to negative 3, and finally dividing by 2 gives us x is equal to negative 3 halves. Now I'm going to bring this 0 into the solution, so I have x equals negative 3 halves. I'll put comma 0, and that's how I'll express this solution. Here we have a trinomial that equals 0. 2x squared plus 15x plus 18 is equal to 0. And I notice that the trinomial on the left-hand side can be factored. Once it's factored, we'll have a product, and then we can apply the zero product property. To factor something like this, well, we know we're going to have a couple of sets of parentheses. Don't lose the fact that this is an equation. A lot of times folks will leave off that equals 0. Since the first term is 2x squared, I should have things that multiply to be 2x squared. So I'll factor that as 2x and x. Since the last term is 18, I should have things that multiply to be 18. That's going to be a 6 and a 3. So we have 2x with 3 and then x with 6, both in parentheses. Now finally I notice that the last term has a positive sign the middle term has a positive sign. And so both of these factors should have plus signs in the middle. We have 2x plus 3 times x plus 6 is equal to 0. Here I have two things multiplying together to give me 0. That means that either the first one, 2x plus 3, is equal to 0, or the second one, x plus 6, is equal to 0. Solving as before gives us 2x equals negative 3. Dividing by 2 gives me x equals negative 3 halves. And then for the second one, the x plus 6 equals 0. Subtracting 6 from both sides gives me x equals negative 6. So I'll write those two solutions separated by a comma. In our next example, we have 10x cubed minus 25x minus 15x squared is equal to 0. I see again that we have a greatest common factor that we can factor out. We should do that. It makes things a little easier. And the greatest common factor looks to me like it's going to be 5x. So I'm going to factor out that 5x. That'll leave me with 2x squared minus 5 minus 3x in parentheses is equal to 0 with the 5x outside. Now inside the parentheses I have a trinomial, but I'd much rather have it in descending order. So I'll rewrite that. I have 5x times 2x squared minus 3x minus 5, all in parentheses, is equal to 0. Now we can factor the trinomial. That'll give us 5x times, let's write 2x in those parentheses. Don't forget the equals 0, and let's get to work on the factoring. Now for the first term we have 2x squared. That'll turn out to be 2x and x. And then the last term is negative 5, so I need factors that'll multiply to be negative 5. I'm thinking a minus 5 in the first set of parentheses and a plus 1 in the last set. I kind of guessed my way through this factoring, so I should check it. 2x times x is x squared. Negative 5 times 1 is negative 5. That's not really what we're checking. What we're checking is that 2x times 1, which is 2x, and then negative 5 times x, which is minus 5x, equals negative 3x, the middle term that it's supposed to equal. That works, so we'll move on. First, let me clean this up a bit. Okay, now if we were in a classroom right now, I'd ask the class, how many factors do we have? Most of the students would probably get the wrong answer. X plus 1 is a factor. 2x minus 5 is a factor. X is a factor, and 5 is a factor. So with 5x times the two sets of parentheses, we have 4 factors. Well, any number of things multiplied together giving you 0 means that at least one of them is 0. Notice 5 is not equal to 0. However, x could be 0, 2x minus 5 could be 0, or x plus 1 could be 0. And what we're after is all the values of x that would make this a true equation. So we're going to solve each of these that need to be solved, that is the second and the third ones. And adding 5 to both sides would give me a positive 5. Dividing by 2 will give me 5 halves. For the third one, x plus 1 equals 0. That'll give us x equals negative 1. We already had x equals 0. So I'm going to write down x equals 5 halves, negative 1, 0, separated by commas. And we see that this particular equation had 3 solutions. Next we have the quantity of x plus 2 times the quantity of x squared minus 5x plus 4 equals 0. Well, this is already factored, but if you look closely at the trinomial in the second set of parentheses, it can be factored further. So let's do that. I'm going to rewrite the x minus 2, and then the x squared minus 5x plus 4, it's going to factor into x minus 4 times x minus 1. The whole thing equals 0. Again, don't lose the equal sign. A lot of people do that. How about this? If it starts with an equal sign, it should have an equal sign every step of the way. Okay, well here I have three factors, x minus 2, x minus 4, and x minus 1, that are multiplied to give me 0. That means that x minus 2 is equal to 0, or x minus 4 is equal to 0, or x minus 1 is equal to 0. I think you'll agree that that means that x could be 2, 4, or 1, the three solutions to this, and I write the solutions separated by commas for our final answer. Finally, we have the quantity of x minus 5 times the quantity of x minus 2 is equal to 28. Let's look back at the first slide. Notice we have a zero product property, or the principle of zero products. We do not have a 28 product property. So two factors that multiply together to give me 28, that didn't mean anything. I could have 1 times 28, 4 times 7, 2 times 14. I'm after something that I know is true. And I know that if on the right-hand side these things were to equal 0, I'd be able to draw a conclusion based on that. So what I have to do is rework this equation so that it looks like what we've been seeing in the previous examples. In other words, we need to FOIL the left-hand side. We'll get x squared minus 7x plus 10 is equal to 28. Subtract 28 from both sides, giving us x squared minus 7x minus 18 is equal to 0. And now, since this equals 0, I can solve this by factoring and using the zero product property. Well, x squared minus 7x minus 18 factors pretty easily. I'd say it's probably x minus 9 times x plus 2. Let me verify. Negative 9 times 2 is negative 18. Cool. And negative 9 times x plus 2 times x is going to give me that negative 7x. I have what I'm after. I also have two things multiplied together to give me 0. That means, let's cut to the chase, that x is either 9 or negative 2.